All right, check it out. So they want us to evaluate these logarithmic expressions without a calculator. So recall the interpretation here. We want this to become that, and it is a matter of an exponent. So 8 raised to what power turns it into 64? Well, we can soon see that the necessary exponent would be 2, because 8 to the power of 2 is 64. Okay? Now, over here, number 2, 7 to the power of what turns it into 343? You can check it, but it should be 3, right? Because 7 to the power of 3 is 7 times 7 times 7, which does in fact give you 343. How about over here? Log 5, 1. Well, 5 to what power turns it into 1? That actually ends up being the 0 power, because 5 to the power of 0, if you type that into your devices, 5 to the power of 0 is going to be 1. As a matter of fact, for pretty much most applications, as soon as you see the number 1 playing the role of the argument, then the result is going to be 0. In pretty much most cases, but not all, but in pretty much most cases, as soon as that's a 1, that's a 0. All right? How about over here? Log 7, 7. Well, that has to be 1, because 7 to the power of 1 gives you back the same 7. See that? There it is. Ooh, now this one here, check it out. This one here. Look, what if the problem, check it out. What if the problem said this instead? If the problem said log base 2 of 64, the result would be 5, because 2 to the power of 5 is 64. But this says 1 over 64. So the trick is you can essentially just turn that into the same number but make it negative, because you can check this. 2 to the power of negative 5, if you type that into your Casios, 2 to the power of negative 5 is 1 over 64. Okay, little trick there. And this could have been done in a different way, and we'll look at that soon enough. Now this one down here, 1/2 wants to become 1/8. It actually is just 3, because 1/2 to the power of 3 is a half times a half times a half, which is the desired 1/8. So that was just the power of 3, and it's not negative 3, it'd just be 3, because 1/2 to the third power is 1/8. Now, as it pertains to solving equations, so for number 7 and number 8, recall the idea of rewriting the expression from log form, from exponential form into log form. So do note what we learned recently, that this equation here is equivalent, in a sense, to saying this here. So as is, this equation looks just like that. If you repackage it to look like a logarithmic equation, it would look like this. It would be log base 13 85 equals x. And the goal was to provide the exact solution. So we're essentially done. This was like a one-step equation. This here is the exact solution. If they wanted a decimal approximation, you could have typed that into your Casios, but that's not what they asked for, so that's not what they get. Here, there's one quick step you have to do for the last one. You want to add the 34 over to the other side first, so as to prepare the equation in a sense. You see that? You add the 4, and that turns it into 35. And now we can go from exponential back into logarithmic form, and that would say this. Log base 16 of 35 equals a, and so we are essentially done. A equals log base 16 of 35. So you guys know that these techniques are going to become more interesting as time goes, and so next time we meet, we'll do something a little more advanced.